23rd.
Okay, I need your attention for this because it's so simple. If you don't pay attention, you're going to get lost, and it's a shame because it's really, really easy. The complex plane. Do you remember the complex numbers?
The imaginary numbers.
Imaginary numbers. And a complex number was in what? How would you write it? Do you remember? Yes, but that's if it's imaginary. But if it's complex?
A plus BI.
Very good. That's if it's complex. Okay. There's something that is similar to this that you've seen, and it's polar and rectangular coordinates, correct?
Yes.
Would you, if I were to ask you, does this look like a polar coordinate or like a rectangular coordinate? What would you say?
Polar.
Polar.
Rectangular.
How do you write a polar?
With the angle.
With this, right?
Mm-hmm.
So it would be, I don't know, 3 and 40 degrees.
Oh, it would be
Does that look like this?
It would be 3 like with the.
So you were right, Ivan. Rectangular coordinates. Because the rectangular coordinates would be something like this.
Uh-oh.
You remember this?
Yes.
Right. So can we make an analogy between this and this?
Yes.
If we can, then this would be the y, and this would be the x. Would you agree?
Yes.
Yeah? Sort of just to make an analogy because then it's easier to understand. So, if you get something along the lines of so if the complex numbers are to rectangular coordinates as polar coordinates are to what? We don't know yet, right? So let me introduce you to something called
I don't want introduction. Oh no.
cis. This would be 3 cis 40. And then in your faces, you're gonna get this. A big question mark. What is that? Right. So let me tell you what it is. Cis, when we take it, we break it up and it means this. It means cosine of 40 plus I sine of 40. Okay? Cosine, I sine. Okay? So let me give you an example of what you are going to get and what to do with it. Right now I haven't shown you anything except that I introduced this weird thing that says cis. Okay? And I made an analogy between the rectangular coordinates that you know with complex numbers and the polar coordinates which you know with the complex numbers written in a different way. So this is like the polar coordinates of complex numbers. Does that make sense?
That's the complex plane right now.
Not yet. I'm getting there. This is the polar form of complex numbers. Okay? Does that make sense? So what are we going to do? What are they going to give you? And then you'll understand everything and it'll come together. You ready? I'm trying to... Okay. So if they give you something like this. 2 square root of 3 plus 2i. Is that polar or rectangular? Right off the bat.
Rectangular.
Rectangular. Okay. So what do you do when you have rectangular coordinates? You graph it, right? So let's put it here, and I get. I can't see. Okay, so it would be 2 and square root of 3 in the x. So here. 2 square root of 3. And 2i. Since they're both positive, I know they are here. Correct? Or here. 2i. So, how do I find this one? It's here. And you're going to look just like you did before. before for the angle, which would be this one, right? And the magnitude. So how do you go about it? What do you do? It would be m would equal 2I squared.
M squared would equal 2I squared plus. Oh yeah.
Plus 2 squared.
Plus
Plus
2 squared root of 3 squared.
Which would be negative 4
Yeah,
plus 4
6.
times 3,
12.
right?
This one.
You forgot the square root over everything.
And that's 12
4
minus 4 is 8.
2 squared.
It's
2 square root 2.
2 square root 2. Okay, 2 square root 2. Does everybody see that one?
Yes.
And then how do you find the angle? Same exact way as you did before. You've got, oh, sorry, this is not the I. You take the I away. My bad, my bad. Ah, my bad. Sorry.
So then.
So this is just, this is 16. And then this 4. Sorry, my mistake. Okay, you don't put the I, you know that the I is here. So that means that we have, the angle would be inverse tangent of opposite 2 over 2 square root of 3. So 1 over square root of 3, that would be how much? Somebody please. 1 over square root of 3 is 30? It's, no,
30. Yeah.
it's 60. 60 degrees. Okay, so how would you write this? You would write it like this. 4 cis 60.
Oh my
And
god.
that's it.
Why? Because it would be 4 cosine of 60, I sine of 60, which brings you back to this and this. Okay? Make sense? Sort of? The silence is killing me.
Yes, miss, yes.
You get it? It's good? Okay.
No, I have a question.
Yes,
Why don't you put the I when you in the graph?
I do. It's here.
No, no,
Ah, in the graph,
Uh-huh.
because this just tells you where to place it. We know that the eyes are always vertical, and the real numbers are always horizontal. Okay? Other questions?
No.
We're good? So, that is that. So what happens if they tell you to add something like this?
You're not done?
No, just really quickly. The last part. The last part tells you if we multiply something like this, 5 cis 20 times 6 cis 42. This is going to be 5 times 6 cis 20 plus 42. Isn't that cool?
I know.
So it's really easy. It's 30 cis 62. That is how you multiply complex vectors in polar form.
That's it.
Wait. You have changed
Oh my
the
God.
20. So you changed the 6.
So the angles you add and the magnitudes you multiply. Basically. Okay? Pretty easy, right?